Hello everyone. In this particular video, we will be discussing about the central limit theorem. So let us start. Let us consider if I have a random variable x which belongs to a distribution D, which is defined by mean and standard deviation. So the random variable x has a distribution D. This distribution can be either Gaussian distribution or any other distribution. So this is not necessarily a Gaussian distribution. X can be any distribution apart from Gaussian distribution as well. And this distribution has some mean and some standard deviation. So this defines my population data. Now suppose if I take a sample S1 containing 30 data points randomly selected from the population X. So S1 is containing 30 data points, say X1, X2 up to X30. This sample itself has a mean which is equal to say X1 bar. Similarly, if I take another sample also containing 30 points, again selected randomly from the population X. Suppose this sample contains data points as say Y1, Y2 up to so on, Y30, and it has a mean equal to X2 bar. In the same way, I take enough number of samples, say I'm taking 100 samples. This sample as well containing 30 data points selected randomly from the population X. Say the data points are Z1, Z2 up to Z30, and it has a mean which is equal to X100 bar. Now if I see, I get another data set containing all the sample means. This data set contains all the sample means and hence it has 100 elements. Now, as per the central limit theorem, if I plot the sample means of all the 100 samples, I will get a normal distribution. This normal distribution that we have got will also have a mean and a standard deviation. I call the standard deviation as sigma dash. So as per the central limit theorem, the mean of all the sample means, that is x bar, will be similar to mu. That is, it will be nearly equal to the population mean. And the standard deviation of this normal distribution will be nearly equal to the standard deviation of the population divided by under root of n, where n is number of sample points. In this case, the number of sample points was 30. So this is what central limit theorem tells us. So as we saw, the central limit theorem specifies that whenever a random sample of size n is taken from any distribution with mean and variance, then the sample mean will be approximately normally distributed with mean and variance. In other words, the central limit theorem states that regardless of the variable's distribution in population, the sampling distribution of the mean, that is, the distribution all the sample means, will tend to approximate the normal distribution, which in turn will be having a mean and standard deviation. The mean of the obtained normal distribution of all the sample means will be nearly equal to the population mean, and the standard deviation of the obtained normal distribution will be nearly equal to the population's standard deviation divided by under root of n. Another important point is that larger the value of sample size, that is n, larger the value of n, better will be the approximation to the normal distribution. Ideally, for a central limit theorem, the value of n, that is number of data points in each sample, must be greater than or equal to 30. So that was all about the central limit theorem. I hope you understood the concept. If you liked the video, please don't forget to hit the like button and subscribe to the channel. Thank you.